Hello friends, now we are starting the last and the very important definition from vectors, that is vector triple product. Already we have seen what is the definition of scalar triple product, properties of scalar triple product in the last video. Even we have proved two theorems also. One is to find out volume of a parallelepiped and one is to find out volume of a tetrahedron. Now let us see how this vector triple product is denoted. Here also we are finding triple. Triple means we are finding product of three vectors in such a way that the result is which quantity? Vector quantity. That's why it is called as vector triple product. So it is if A bar, B bar, C bar are any three vector, then their triple product is denoted by A bar cross B bar cross C bar. Means here bracket is given to last two vector. Try to understand, this definition is applicable if bracket is given to a last two vector. A bar cross B bar cross C bar is defined as A bar dot C bar into B bar, means A bar dot C bar into B bar minus A bar dot B bar into C bar, A bar dot B bar into C bar. So you have to remember this definition. We will discuss some techniques also to remember this definition. So here let us denote this first vector say by 1, second vector say by 2 and third vector by 3. Means we have denoted A bar by 1, B bar by 2, then C bar by what? 3. So on this side, A bar means what? 1, C bar means what? 3, B bar means what? 2. Here A bar means 1, B bar means what? 2 and C bar is what? 3. So here A bar is 1, B bar is 2, C bar is 3. So now what we are getting on this side? 1, 3, 2, 1, 2, 3. So you easily we are able to remember these numbers. First number is always what? 1. First number is 1. In both the cases, first number is 1. Now only the remaining part is to arrange remaining two numbers. Which two number? 2 and 3. Here 3 2 is there and here 2 3 is there. Means what is first number? 132, 132 and second number is 123. Which number is greater? 132. So first write down greater number minus what? Smaller number. In this way simply we are able to remember this definition, that 132 minus 123. Getting it? This definition is applicable if bracket is given to what? Last two vectors. Then applying this definition we are able to find out vector triple product. Why we can say that it is vector triple product? Because cross product of two vector is a new vector, and whatever may be the new vector we are getting here, we are taking its cross product with A bar, and cross product of two vector is what? Vector quantity, means finally result will be the vector quantity. That's why if we are taking product in this form, then the result will be vector. That's why it is called as vector triple product. Now instead of A bar, B bar, C bar, if the vectors are denoted say by P bar cross Q bar cross R bar, at that time what result we will get? 1, 3, 2 means what we will get? 1 means P bar, 3 means what? R bar, and 2 means what? Q bar. First take the dot product of these two vector into Q bar, keep it as it is, minus again here what we'll get? 1 2 3. 1 means what? P bar, 2 means what? Q bar, and 3 means what? R bar. So here just simply give the dot here. So now 132 minus 123. In this way we are able to remember the definition of what? A vector triple product. Hope the idea about how to apply this definition is clear. Now here A bar dot C bar. A bar dot C bar means dot product of two vector, and dot product of two vector is which quantity? Scalar quantity. Scalar means here we are getting one number. So let us denote this. This will be one number. Whatever the number we are getting, we are multiplying by this number to what? B bar. And here also dot product of two vector is what? Scalar means number. So here we will get number, that number into what? C bar. Means here we will get, let us denote this number say by X and this number by what? So what we will get here? XB bar minus Y C bar. Such type of expression we will get applying the definition of cross product. In this A bar cross B bar cross C bar, this first vector A bar is called outer vector, where the second vector B bar is adjacent to A bar. B bar is what? Adjacent. Adjacent to it means adjacent to A bar, and this C bar is called as remote vector. C bar is called as remote vector. So same definition can be remembered as. So this first vector is what? First vector is outer. Second is what? Adjacent. Third is what? Remote. So what we will get here? Outer into remote, outer dot remote into adjacent. So here we will get outer remote into adjacent. Minus keep it as it is. A bar means what? Outer. B bar means what? Adjacent. C bar means what? Remote. So here what we will get? Outer adjacent into remote. Outer adjacent into remote. So you are able to remember this definition by using these notations also. A bar is called as outer, B bar is called as adjacent, and C bar is called as what? Remote vector. Isn't it? If we are giving the name to this vector by outer, adjacent, remote, then you are able to remember this definition also. But simple ways to remember this definition is what? 132 minus 123. 132 minus 123. Now, using this definition, now let us discuss some properties. Properties of vector triple product. So now let us discuss about the properties of vector triple product. So observe the first property. Let us consider that this bracket is bracket. In this bracket, cross product of two vector is there, and we know that cross product of two vector is new vector. Let us denote this new vector say by d bar. So what we will get here? A bar cross d bar. And we know that in case of cross product, A bar cross D bar and D bar cross A bar are equal or unequal. Definitely they are not equal, because we have seen that cross product is not commutative. Means these two values are unequal. Their magnitudes are equal, but directions are what? Opposite. And since directions are opposite, that it will be denoted by what? Negative sign. So here also this A bar cross B bar can be written as minus B bar cross A bar. I am just considering this whole bracket as what? D bar. So according to this result which already we have seen in cross product. Now we are trying to find out value of A bar cross B bar cross C bar. Means observe the difference between these two terms. Here bracket is given to last two vector, and here bracket is given to what? First two vector. If bracket is given to first two vector, at that time using the same definition we are finding this value. Means we are finding the value of A bar cross B bar cross C bar is equals to. Now just now we have seen that this A bar cross B bar can be written as minus B bar cross A bar. A bar is here, A bar cross B bar. Just if we are interchanging these two vectors, sign will get changed according to this property of vector, according to property of cross product of two vector. Minus keep it as it is. Now if you will observe here, bracket is given to what? Last two vector. Bracket is given to last two vector. So we are able to apply this definition. According to this definition, what we will get? 1, 2, 3. If we are denoting this first vector by 1, second by 2 and third by 3, then according to this definition, what result we are getting? 1, 3, 2 minus 1, 2, 3. 1, 3, 2. 2 means what? B bar. Sorry, 1, 3, 2. 3 is what here? B bar. And 2 is what here? A bar. So 1, 3, 2. Here give the bracket to first vector, and what is the operation in first two vector is dot product. Minus 1, 2, 3. 1, 2, 3 means C bar, A bar, B bar. Here give the dot product and into what? B bar. So this result we have got applying same definition. Now we are multiplying by minus to both the terms in this bracket. So if we are multiplying to second term, minus into minus will become plus. So first write down this positive term, C bar dot A bar into B bar, and then write down this second term, minus into C bar dot B bar into A bar. Now we know that dot product is commutative, means A bar dot B bar can also be written as what? B bar dot A bar. In the same way, C bar dot A bar can be written as A bar dot C bar into B bar, minus here C bar dot B bar can be written as B bar dot C bar into A bar. And check that we have got this result. So hope idea about how to find out the value of cross product is clear to you. If bracket is given to what? First two term, isn't it? Now if you observe the value of A bar cross B bar cross C bar, here the value is in terms of which two vector? B bar and A bar. Value is in terms of what? B bar and A bar. And if you observe the value of A bar cross B bar cross C bar, means if bracket is given to last two vector, at that time its value is in terms of B bar and C bar. Here value is in terms of B bar and A bar. Here value is in terms of B bar and C bar. Means we can observe that these right hand sides are unequal, and since the right hand sides are unequal, that's why we can say that these left hand sides are also what? Unequal. That's why we can say that A bar cross B bar cross C bar is not equal to A bar cross B bar cross C bar, isn't it? Now here this a bar dot c bar is what? One number. Let us denote this number say by x. So here we will get x b bar minus, here also dot product of two vector is number. Let us denote this number say by y a bar. So such type of expression x b bar minus y a bar is called as what? Linear combination. Linear combination of which two vector? B bar and a bar. Already we have studied about linear combination in earlier videos. Even we have proved some theorems also, and we have solved one exercise also on what? Linear combination. Well, such type of expression is called as what? Linear combination of which two vector? B bar and a bar. Means we can say that value of vector triple product is the linear combination of two vector. That's why here we have written that value of triple product is the linear combination of, in this definition, it is linear combination of which two vector? B bar and C bar. So value of a bar cross, here bracket is given to what? Last two vectors. So bracket is given to last two vector. So value of this vector triple product is linear combination of which two vector? B bar and C bar. Means it is a vector quantity. Triple product of three vector is what? Vector quantity. And this vector is expressed by what? Linear combination of other two vector. Then again we have seen that if one vector is expressed by linear combination of other two vector, at that time three vectors are what? Coplanar. That is the condition of coplanarity, which we have studied in what? Linear combination. If one vector is expressed by linear combination of other two vector, at that time three vectors are coplanar. Means this is what? First vector. This is first vector, this is second vector, and this is third vector. Means we can say that this new vector which you are getting after taking vector triple product, it's coplanar with what? It's coplanar with B bar and C bar. So that's why we have written that this vector is expressed as linear combination of B bar and C bar, and hence is coplanar with B bar and C bar. So we in second theorem we have proved that if one vector is expressed by linear combination of other two vector, at that time three vectors are what? Coplanar. So this is first vector which is coplanar with which two vector? B bar and C bar. So remember this also, and one of the important result. Lastly, we will discuss about cross product of basic vector, vector triple product of basic vector I cap cross j cap cross k cap. So here we are discussing the vector triple product of I cap cross j cap cross k cap. Already keep this first term as it is, I cap as it is. So j cap cross k cap is nothing but what? I cap. So hope already we have seen that if we are arranging these vectors in anti-clockwise direction, then what result we will get? J cap cross k cap will be equals to what? I cap. Now we have got here cross product of these two vector is I cap. And we know that cross product of same vector is always equal to what? 0. Means what result we have got here? This vector triple product of basic vector is equal to what? 0. All these are nothing but what? Properties. Properties of vector triple product. So this is the definition. Simply we are able to remember it as what? 1, 3, 2 minus 1, 2, 3. If the bracket is, instead of giving bracket to last two vector, if bracket is given to what? First two vector, at that time also the result what we are getting here, this is first vector, so this is third vector, this is what? Second vector. Here also we are getting 1, 3, 2, here also we are getting 1, 3, 2. But here some changes are there. Here what we are getting? 2, 3, 1. So 1, 3, 2 minus, here what we are getting? 1, 3, 2 minus 1, 2, 3. But instead of giving bracket to last two vector, if bracket is given to what? First two vector, at that time first term we are getting same 1, 3, 2. But my second term is here what? 1, 2, 3, and here 3, 2, 1. Sorry, 2, 3, 1. Getting it? So remember these important properties which you are getting from the definition of what? Vector triple product. Now in the next video we will discuss, we will solve the last exercise from this chapter. Here we have completed the theoretical part of vectors. Now only the remaining part in this chapter is last exercise and miscellaneous exercise.